Okay, let a and b are integers having that the greatest common divisor of them is d. So d is the largest common divisor of a and b. Keep that one in your mind. Then the conclusion is these two integers a over d and b over d has no common integer except 1. Of course, who says a over d and b over d are the integers? The only reason is because d is a divisor of a and b. Therefore, even after divide a by d, the result must be still an integer. Same thing for here. So we can calculate the greatest common divisor of between these two numbers because they are integers, and the result must be 1. That's the claim of this theorem. Okay, let's prove it. Let's say there is some kind of common divisor of these two numbers. So let's say that is e. At this moment, we don't know whether this number e is 1 or not, but let's just say it. Okay? Then, by the definition of divisor, if e is a divisor of a over d, then there is a certain integer l satisfying the number a over d can be written by e times l, because e is a divisor of a over d. So we got this equation. Same thing for here. So because e is a divisor of b over d, there is a certain integer k, and it's satisfying that e times k is b over d. Then if you multiply d on both sides here, we got a equals d times e times l. And from here, b equals d times e times k by multiplying d on both sides. Then clearly from these two results, we know that d times e is a common divisor of a and b at the same time. But we are already assuming that the greatest common divisor of a and b is d, and we found new common divisor of a and b, which is d times e. Therefore, d times e must be less than equal to d, because d is the greatest common divisor of a and b. Then, when do we have such cases? When d is a positive integer, then e should be another integer. Therefore, it must be just 1. There is no other way to get that one. Therefore, what? The common divisor of a over d and b over d is 1 only. There is no other such case, right? Therefore, we just prove the greatest common divisor of a over d and b over d is 1. That's the end of the proof.